Hello there everyone. I did say I was going to start today's lesson by going through the final question, like the exam question on last week's lesson. So here we go. Here's the first part, which is the main meat of it really. And it says, given that the data can be modelled by an equation in the form that, that's where I would start. And I would say, I know I'm going to have to take the log of both sides. So that's going to give me log g is equal to log ab to the power t, and then I'm going to say multiplicative law would give me log a plus log b to the power t there, and then I would say product rule means that that's going to give me t many of these log b's, so t log b there. And then I would think to myself, right, that's log g. We're going to be plotting. They're saying that y is log g and x is t. So given that, I'm going to be having an equation here, 0.09 is what that is there, and that is log a. So I can say first of all log a is equal to 0.09, and that means log, basic log there is log with a little 10 down there, isn't it? So we're saying 10 to the power 0.09 is a, so 10 to the power 0.09 equals a. Get out the calculator, and 10 to 0.9 equals 1.230. So to three significant figures, that's going to be, but I always insist on writing down the first four things like that, and then I want those three digits, don't I? So 1.23 to three significant figures is A. And then for B, well, what's the gradient this time? Because we've just got t along here, the gradient is going to be what we're timesing t by in our equation. So the gradient is log b. So I'm just going to write down gradient equals log b. So I know that the gradient is 0.05, which is log b. And we're into the same situation again, aren't we? Base 10, so b is going to be 10 to the power 0.05. So we're back to here, and we're saying 10 to the power 0.05 is equal to 1.122, so to three significant figures, b is going to be 1.12. So finally, as an interpretation of the constant b in this equation, well, b is the value when we're thinking about they're saying that it's g equals a b to the power t. So what that's meaning is that the rate of change is governed by this, isn't it? Because it's this to the power. So b is a measure of the rate of change for each degree of temperature. And explain why this model is not reliable for estimating growth of the population when the temperature is 35 degrees. Well, to look at that, look at this, and 35 degrees would be right up here somewhere on the table. So that would mean extrapolating the data, which would not be reliable because we don't know anything about how this colony acts when it gets that much hotter. Okay, so that's that. We will now move on to today's main thing. Right, today we're looking at something called the product moment correlation coefficient, which is summed up by the letter R. And what's that all about? That's about saying how strongly you can predict something. So yesterday we were, or last week, whenever you did the last video, we were looking at creating a straight line from our growth or regression data, and then having a look to see how, and everything should perfectly fit on a straight line. Now if it did, that would be a product moment correlation coefficient of 1 if it was going in a positive direction. So there's only this one here would be an R value of 1 because all those data points are lying exactly on that line. That means if I was to give you whatever the X and Y, but a bit of data for there, you could predict exactly what the one should be over on Y, as long as it came between the values we know for. And it doesn't matter how steep that line is, it's about how close to the line of best fit we are. So there's also one on here which is a perfect negative one, and that's this one over here. Now it's not as steep, but that doesn't matter because you don't know what the scales are here anyway. The important thing is whether or not it's totally predictable. So if it's a negative correlation, so as one thing gets smaller, the other is getting bigger and vice versa, and you can predict exactly what the other one's going to be, that's from a perfectly strong negative correlation. So that would be R is negative 1. If things are loosely based around here, but it's clearly negative, then that would, when we do the calculation you need to do to work this out, should give you something around about negative 0.8. Here, there's no line of best fit drawn because there's no correlation. So if there's no correlation, that would give you an R value of 0. Your R value is always going to lie somewhere between negative 1 and positive 1. This is your perfect, your total negative correlation. This is your total positive correlation. This is somewhere in between. This is somewhere in between. This is no correlation whatsoever. Now this one's more loosely based. In fact, it's very loose, isn't it? But it definitely is a positive correlation. So that would be, oh, I don't know, about 0.2, 0.3, something like that. And that's what we're trying to find the measure of. Now, there is a way with a really big calculation you can work out your product moment correlation coefficient. It would be to get the standard deviation of the X to the Y datas, so for each one of those, and divide that by, hang on for this one, the square root of the standard deviation of all your X data points, multiplied by all of your Y, the standard deviation of all of your Y values. Do the root of all of that, divide it by that, that would give you the R. Now there's more calculating to be thought about than just that, because in order to do standard deviation, you're actually saying, right, I'm going to be working out the sum of all of the x's times the y's for this one, and I'm going to be taking away the sum of the x's times the sum of the y's, all divided by how many data points I've got. So that would be the standard deviation of the x, y's. We're going to be doing within that this standard deviation, which you would be working out by summing all of the x squareds and then taking away the sum squared divided by how many we've got, taking away the mean squared, wouldn't you? And then, so that would all have to be in a bracket, and then that would be being multiplied by doing the same thing for all the y's. So that's carrying on here. Don't worry about writing all of this down unless you want to try. So this is what we need to do. Now we can do it by putting our values into the calculator, and that's what I'm going to show you next. Right, here's today's question. Fantastic stuff taken from the large data set, but we don't need to know anything more about it as far as where Herne is and all that sort of stuff on this particular question. What we do have is we've got the wind in knots, the W going across here. Don't worry about copying this table down, by the way. The only key we're going to be doing here is a bit of calculator usage, so you may need to pause and rewind the video once or twice just to make sure you've got things, and let me know if you can't work out what's going on. Part A says state the meaning of n stroke A on there, so that's a really easy mark. There's no data given for there, so we don't know anything about the strength of the maximum gust on days 8 or 9, which just means we can't use that data. Right, now the thing we need to do is calculate the product moment correlation coefficient for the remaining 8 days. So we're not going to put those two values in. We're going to need to put all this data into the calculator on so that is statistics mode, and here it is. I fire it up and the lists are all a little bit wrong, so I'm going to get rid of those. So how do I clear that? I go to delete all, F1, go across to list 2, delete all of that, F1, and then going back on to the top of there, I'm just going to put in the data. So for list 1, 4, 4, 8, 7, 12, this is fun, isn't it? 12, 3, don't bother with the 4 and the 7, and then just put the 10 in there because we didn't have any data for the 4 and the 7 in terms of gusts. Now putting the gusts in, 13, 12, 9, 19, 23, 33, 37, 10, and the last one being 23. Now we're expecting to get a positive relationship going on here, because a windier day is going to have the biggest gust you would have thought. So now that we've put all of that in there, if I get myself to where it says graph, if you hit graph and any one of these 3 graphs, you can set them up beforehand, but don't worry about that. That just shows what your scatter graph would look like if you'd been asked to plot a scatter graph. Anyway, we haven't, so we're going to go on to calculate, and you want to just check that your 2 var is looking right. So if we go on to set, we've set up our calculators before for using frequency for one list of things and how many of it is, but the important thing is that one of these things has got just an X list and a Y list. So the first thing we put down is our X values, the second thing is our Y values. So as long as we've got that, then that's okay. If you haven't, then you want to reset those. Now that we've got that, all I have to do is go to reg, and then it says where it says X, if I press F1 on that to select that. Now it doesn't matter which one of these two I pick, some values will be different, but the one that we want is R. So my R, this is my product moment correlation coefficient is 0.95329, and when we're dealing with a lot of these things, we generally go to 4 decimal places, so we are looking at that. So we're looking at 0.9533, which is a very strong positive coefficient. And with reference to your answer to part B, comment on the suitability of a linear regression model for these data. So R is very close to 1. You'd want to write something about, so you could say that there is a R is close to 1, so there is a strong positive correlation, meaning the linear regression model is suitable. Now, to practice this out, we're going for exercise 1b. I'd like to have a go at questions 1, 4, 5 and 7. And if you want to do more than that, it's not a bad idea, because the more you do this, the more likely you are to remember how to use it. It's one of those things comes up in the exam. If you can't remember how to use that, it's going to take ages to do all of those standard deviation stuff. And let's face it, if you can't remember how to do the R bit, you probably can't remember what you're doing with your standard deviations, and the fact that you've got those 3 different standard deviation calculations and how to put all of that there. So good luck with that, folks.